on the grid shown. What is the scaling factor needed to dilate ABC so that it is congruent to DEF? Show how you arrived at your answer. So in this one, we can actually come up with a hard number. It's going to be, okay, my scaling factor is 3, or it's 1/3, or something like that. See if you can figure out what the scaling factor is. Okay, remember, to dilate ABC, so this is the old, to get DEF, and that's the new. Go ahead, think about that for a minute. All right, let's go through it. Well, all you really have to do is come up with two sides that correspond to one another and divide their lengths, taking the new length and dividing it by the older length. Two of the three lengths are very, very convenient. One of them is not, and that's that hypotenuse. For me, I would simply take the length of DE, which looks to be 6 units long, and divide it by the length of AB, which is 4 units long. And when I do that, I would get a dilation constant of 1.5. Or 3/2, you could leave it as in fraction form. You would get exactly the same thing if you took the length of EF, which is 12, and you divided it by the length of BC, which is 8. And that is also 3/2, or 1.5. Again, new divided by old. If we were going the other way around, by the way, if they had said, well, what dilation constant would you have to use to make DEF congruent to ABC, then both of these fractions would be reversed and we'd get a dilation factor of 2/3, or 0.666 repeated, 0.67 if you rounded it to a reasonable amount. Remember that direction matters, because are we taking a smaller object and making it larger, or vice versa? Let's take a look at letter B. Specify a similarity transformation that would map ABC onto DEF. All right, well, let me get rid of all this mess so that we can kind of look at this a little bit easier. So now I want that step 1, step 2, step 3 thing. Why don't you go ahead and take a shot at this? Okay, there's many different correct answers. We'll take a look at one of them. All right, let's go through it. I'm going to even try to trace out ABC to see if I've got a working model that I can trace with. Hopefully that'll work. Ah, lovely. All right. So let's do it. I want to do exactly what I did before. I want to get two vertices matching up that I know have the same angle. And probably the easiest thing to do is get B to match up with E. So first thing I'm going to do is I'm going to translate triangle ABC so that B maps to E. So this thing is going to come up kind of like that, right? All right, that's not bad. Now what I'd like to do, though, is I'd like to have it in the same orientation. So I want to reflect that. So the second thing I'm going to do is I'm going to reflect triangle A prime, B prime, C prime across what? Well, you could describe it in many different ways. I want to reflect it across this vertical line. So you could give that equation. You could say, I'm coming across the line x equals 3. That's that vertical line. Or you could just say across EF, right? You don't even have to use the equation, even though we're in the coordinate grid. You could just say, I'm going to reflect it across EF. Let's do that. Hopefully it will allow me to. Let's flip this thing left, right. All right. And that would end up, making it look kind of like that. I won't waste your time by trying to get it exactly. But now again, look, we've got the two triangles in exactly the same orientation. So now all we need is that final dilation piece. Let me bring it up just a little bit. And now let's dilate triangle A double prime, B double prime, C double prime with a center at E. And we've already figured out the constant and a scale factor. Here's my magic red. Scale factor of K equals 1.5. All right. I like the coordinate grid because oftentimes we can give that scale factor in a precise numerical form. We don't just have to say, oh, it's DE divided by BC or something like that. We can literally say, okay, I did the division and I got 1.5. Let me step out of the way for a second so you can take a look at this, and then we'll move on to do more. All right, let's take a look at the last problem.